we will go. Okay, so ladies and gentlemen, to finish this up, what we will do is I believe I've saved away the very latest version here, version 3. But in case I haven't, I will stick it up on the network there, and anyone can get it. So I'm just getting this network cable in to be sure that we have this network connectivity. Good. We're cooking with gas. It's this GIS model 3, and I will copy it into this model's built-in class. This includes the requisite icons. GIS model 3, version 3 is there, okay? Here we go. Okay, so anyone can go get it. Next, what I'm going to do is we are going to have them actually present for care at the clinic. And in order for that to happen, we need to map out clinic workflow. So I'm going to go now to open up clinic from the project area, okay? I'm going to double click and open up clinic. So I put that model up there for you to download, version 3, if you want to get it. Otherwise, I'm going to go to clinic here, open up clinic, and we are going to add what are called discrete event components to the clinic model. Okay? You can go here to this palette to find discrete event components up here at the top, okay? In the process modeling library. What we're going to do is go down, and we are going to place within the clinic a set of components in order. These components will include a arrival component and an exit component and a set of measurement components. And then we are going to have people present to the clinic in order to undertake it. So to undertake the entry into the action. So to clinic, we go to this thing. It's called something like IL or IML. It's up here. And we drag here for an enter action. If any of you TAs have stakeholders that have left the room because they want to work on projects, I'd encourage you to go there. We don't need all TAs here for this session. We have a smaller number of people. So please go to your stakeholders as they saw fit. Okay? So we've just dragged in an enter component. And we are now going to add in, further than that, a component which is going to measure time. Okay? So there'll be a time measure start component, and I want to connect it with the component we just added. So it's this one here. Okay? We're going to connect it up. What that means is an entity or agent that comes in here will proceed here. Next, we're going to add in a component that's going to represent a procedure called delay. Okay? And we're going to call this workup. Okay? Actually, it'll be called treat. Treat. Okay? Not as in trick or treat, but as in like treat them. That's wherein the healing beam will first be located. The sort of dream of biomedical scientists. Okay? The beam will be present in the treatment. Okay? And next, we're going to put in a time measure end, which again has to come from down here. Time measure end. So that's going to measure the time from the start to the end. And when we put in the time measure end, we need to tell it from what point to start recording time. So for time measure end, we have to use this plus and pick time measure start. Do you see that? That will mean we want to record the time from this earlier point to this one. Okay. Okay, this thing is getting in the way, so I'm just going to hide it and reset its location. Okay. Next, I am going to add an exit block. Okay. Here we go. An exit, and that will be recording the, or that will be wherein they leave this. Now, a few more things. This treat block, to allow multiple, right now it has a capacity of 1, okay? And what that means is that people will, only one person can undergo the healing beam at a single time. So we need something that's going to batch people up in a queue before that, or else they will not be able to be fit there and it won't be able to handle it. So we're going to add in further here a queue. Okay, we're going to drag in here a queue, which is going to occur before treatment. So they await the queue before they enter the healing beam. Okay, and the queue is going to have maximum capacity associated with it. So people are going to enter. They're going to flow down here, and they can enter the treatment beam if no one else is there, but they will. They can wait in the queue if someone else is occupying the treatment beam and continue on. Okay. Okay. So, ladies and gentlemen, that's the idea behind this. We're going to have to refine this, but that's the idea right now. Great. Now, there's two sides of this because, first of all, we need the people, when they present to care, to not merely physically go to the clinic. They have to logically enter here. They have to enter the workflow. That's one side of a reciprocal relationship. So we're going to have to go back to person. Let's go to person. And where is it that they enter care here? Where do they enter the care? Well, yeah, when they enter this block of under care. Not only should they move to there, but we're actually modeling them as getting in line, okay? So what they need to do is they need to go to the nearest clinic, and they need to then undergo care, okay? Now, you notice we've already computed the nearest clinic here. So we're going to remember that so that we can enroll them in that same clinic. So we're going to do something we've never done before, which is we're going to create what's called a variable. We're going to call it nearest clinic. Nearest clinic, that's what this is. It's a clinic. Nearest clinic equals, and it's going to be this get nearest clinic. Okay? Here it is. Get nearest clinic. There we go. And they're going to move to the nearest clinic. That's already been something we did. And thirdly, they're going to enroll themselves in said clinic. So we'll do this dot nearest, oh sorry, we'll do nearest clinic dot enter dot take me. Okay, this is this. I'm being taken into the clinic. This enter thing there is just the name of this first thing. I prefer to generally call it walk-in, and we could have named it that. So how did I do that? This is all in here, and I'll put it up on the big screen. Here we go. Okay? And I'm just going to build it to make sure it's hunky-dory on mine. And it is. And now I will broadcast it to you. So, this first line names a clinic called nearest clinic, which we obtained through this. We then move to that clinic and we tell the clinic, take me in to its workflow. So this gets us into the clinic. This gets us, into the workflow of the clinic. Okay? Are we okay with that? We've entered the clinic. We've gone to the clinic physically, visually too, and we've entered its workflow. Secondly, we're going to have to come back from the clinic, right? We need to return from the clinic. Right now, people go to the clinic, and in the clinic, they stay. But once they are healed, once they have passed through the proverbial beam, they need to be able to come back, return to their previous state. And we'll assume that following their clinic visit, they will return home. Okay, this is going to lead to a slight synchronization issue. But following their sojourn to the clinic, we'll assume that they return back to their home to recuperate. So here we're going to have a transition back from the clinic to home, and that will be transitioned by a message. Okay, they head back home. They head back to the clinic. Here they go. Okay? And now we'll need to fill in a little detail for this model that we haven't dealt with. We need them to head home when they leave the clinic. We need a way of communicating that for them to head back home. So we need a way for them to say, go home. And they'll go home after they're done with the clinic. So we'd have that triggered. So this is what we need to do. We need to go and in main, not in main, over in project, we're going to need to add in a option list called, so it's an option list called messages. And this is better than sending text for messages. We'll send messages that we know their exact spelling. We're not afraid we'll get it wrong, that we'll put it in capital letters or lowercase. It will tell us. So how did I do that? I went to the model as a whole. I did new option list, and I added in an option list called messages. So I did new option list, and I called it messages. Okay, and within messages, if we go there, either while you're defining it or here, I'm going to go give it several messages. And there's three messages. One is exposed. One message, so I'm entering them here. One message is exposed. One message is return home. And one message is cured. Okay? Cured, ladies and gentlemen. Cured. These gives clear names and names whose correctness of spelling will be checked. These are going to be the three types of messages that we'll use in our model. Okay? And the last one, cured, we'll put in the logic in just a minute. Okay, we're a lot of the way done with this for the healing beam version. Do people need a bit more time? You got it? Okay, next. Go back to person. When a person returns home from the clinic, that will be triggered on a particular message that is called go home. Or messages, did I call it go home or what was it called? Messages dot return home. Okay? Return home. That will send them back home. If they receive that message, okay. I'm getting that weird any logic message. I'm going to close this thing and reopen it here. Here we go. Come on, get back in here. Okay, and here we go. I am going to build it, and it's a happy camper. Okay. So it said it couldn't find a transition. I remember it did that before when it had problems. So I just closed the model and opened it, and we're fine. So in short, I defined this transition as dependent on this message called return home. I say messages dot return home, but we could alternatively just say return home, and that will be fine. So return home, if they get a return home message, they go back home. That brings them, if they're in the order, the under care state, and they get that message, they'll go home. Okay, and once they reach home, they will jump to their home. Next. So do people need a bit more time for that? Got it? Okay, next. So we're getting very, very close to done with this then. Next, for this exposure message here, we'll send to a random connected a message that says, instead of being a string, instead of being in quotes, it'll just say exposed. So if we misspelt it with a lowercase e, by using a clear name in messages, it would tell us that it was misspelled. If we just used a quoted thing, it's not going to know it's misspelled, and it would have let us spell it at our peril. Next, in the infection transition here, we will need to go on a particular message that is exposed. We don't want to go, if we're going home, we don't want to get infected automatically. But exposed here. Exposed. Okay? The exposed message. So what did I do? I just added for 3 transitions. Heading home from the clinic, infection message, I added, each of them are contingent on receiving on a particular message. For going home from the clinic, that message is return home. For this one, from susceptible to exposed, it's exposed. So now we're going to handle multiple messages, and finally, for this one here, we're going to be sending the exposed message rather than sending a quoted thing. Are people okay with that? Who needs more time? Okay. Okay. Anyone need more time? No? Okay. Okay. So we're going to add one final transition here. What is that transition? Sorry? Cured. And where will that transition bring us? From where to where? The dream of biomedical science. The provision of a curing beam to bring the individual from what state to what state? Where does it bring the beam? Where does the beam bring them? From what state to what state? Where do they need to go if they're cured? Infective to susceptible. So let's add that transition in and make it dependent on the cure. Okay? Okay. Do we? Oh, you're right. Oh, we don't have to add it. Thank you, thank you, thank you. You already have it. There's the cure. Okay. And this is going to be on a particular message, and that will be what message? Cured. Cured, ladies and gentlemen. Not in the sense of leather, but in the sense of pasture. Okay? Not in the sense of concrete.
So it's getting this information from the option list?
Yeah. Yeah. It knows the name cured from the option list. By putting it in an option list instead of just strings and quotes, it makes sure we don't misspell it, make sure it's all consistent, gives us one place to look at a list of all messages. It kind of, and it makes the AnyLogic help us more by keeping our naming straight. Okay. The final thing is, whence will that message come? The cured message. Where is the cure imparted? Wherein does the healing beam lie? Sorry? Yeah, in the clinic. And where in the clinic? In the treat state. So, ladies and gentlemen, if we repair to the clinic and we seek out the treat state, and we select it, you'll notice that there's a set of things that can happen here. And what we want to do is we want to go and specify an action when they complete the treatment. The treatment is right now going to take, oh man, I'm glad we checked it. The delay time is what? How long are they in that state? Sorry? How long is it, say, right now? 0.5. It's a triangular distribution from 0.5 seconds to 1 second to 0 to 1.5. A triangular distribution is often used in industrial engineering as sort of an approximation for a measure of sort of a distributions with central tendency. And so this says the minimum time that you will take is 1 second. The minimum time is 0.5 seconds. The maximum is 1.5. And on average, you'll take 1 second to pass, ladies and gentlemen, through the beam, through the healing beam. Okay? Well, for a beam, that may not be objectionable. We'll leave it in place. Well, I think even for a beam, there may be some longer exposure that's needed. So I'm going to say that it's going to take between 0.5 hours, 1.5 hours with a mean of 1 hour. Is that okay? So they have to be bathed in the beam. And that, like someone going to a tanning salon, they'll cure their skin in a tanning salon. They'll expose themselves to a beam for 1.5 hours, and they'll emerge cured in a deeper sense. The dream of biomedical science. We will soon recognize that dream is limited in its applicability. Okay, so I'm going to build this. It's a happy camper, and I would invite you to run it and let us see what happens. Oh, yes. Oh, sorry. We forgot the key thing. We were working towards it. What needs to happen at the point the treatment is conferred, that it's completed? What needs to happen at exit? We need to send a message to whom? To the agent saying what? Cured. So we can say agent, or we can say this dot send, and send it a message to that agent which says that they are henceforth cured. So we have to specify what message to send and then the agent to whom to send it. The message that we're going to send is cured, and we send it to the current agent. You know what? Notice I could tell there was an agent there because it was called agent. Okay? Okay. So here we go. So now the treatment sends a message to the agent. So this is bidirectional. The agent repairs, it presents to the clinic upon illness. They enroll in the clinic workflow. The clinic conveys, ladies and gentlemen, the cure after a due measure of time. The cure sends a message back to the agent. And what will happen when that agent receives that cure? When that curative is received, what will happen? They will go back to susceptible. And then, actually, finally, what do we need to do at the end of the whole clinic workflow? Send them a message to go where? To return to their home and hearth. That's right. So at the exit, we will say, here at the exit, we will indicate that they should go home. How do we indicate that they go home? Send them a message. This dot send, return home, and to whom do we send it? To the agent who's flowing through here. The agent who's flowing through this workflow. Let's build. And now, ladies and gentlemen, let us reap the fruits of our simulation, and let us see the agents going to the clinic. Okay? So here are the agents. They're going back and forth to work. And oh, okay. Is any of them infected here? I actually don't see one of them becoming infected. We saw it earlier.
We didn't change the message in the main.
Ah, good call, John. We didn't change it in main. That's the remaining place, isn't it? So John pointed out that in main we still send a different message to say infected, that they're exposed. And we just screen that out because here we're only paying attention to messages that say exposed here. And we sent them a different message from main. So where did we send them that message in main? Remember that? It was down here in the initial infection. And so I'm going to go there, and instead of sending them a text message that says exposed, I'm going to send them a message like this, that is just the word exposed, not in quotes. It's an option list. It's a so-called enum in Java. Okay, here it is, exposed, just like that. Okay. Tomorrow morning I'll talk about how I change that slightly there, but we'll do that. Okay, who needs help? Who needs TA help? Okay, so where did I go? I went to this event in Maine. I scrolled over to the end and I said exposed here. Okay? Are we okay with that? Exposed at the very end. It used to be quoted and an exclamation point. I got rid of the quotes and the exclamation point, so it just says exposed. Okay, next, we will run it, and what we should see now is agents who present for care following some period of infectivity, and then are cured. Okay, so I'm still not. Are they getting infected in yours? Okay, so in mine, they are not. I put in place what I thought was an improvement. Oh my gosh. Oh my gosh. It just. Okay, I accidentally terminated my any logic. Sorry, I screwed up there. So they're getting infected. Are they getting cured? Okay. The beam is working for you, but not for me. So let me go open up AnyLogic. I'm sorry, I closed it by accident. Okay. So ladies and gentlemen, we have this round trip now. Is it running and individuals are getting cured? Or is the infection staying active in the population, or does it die out? Yours is still going. Okay. So I look forward to joining you in your explorations in just a minute here. I'm going to, whilst just so I'm on exactly the same page with you, I actually figured out a necessary improvement to things during the guest lecture, and I'm going to share it with you tomorrow. But for now, I'll just do exactly what you're doing. Oop. I'm going to change that back to exposed. Here we go. This will be the exposed message. Good. And we'll build it, make sure things are happy. Good. And now we'll run it. There we go. Okay. Okay. We're running it. And here we go. Okay, for some reason in mine,
I believe that the exposed seems to refer to the state in the state chart. So once we change the option list message dot and exposed, and it works.
Okay, so what you're saying is the option list had the same name as this. Got it. So there's two ways we can. Aha. So there's two ways we could handle this.
There is also something else in your stage.
Yeah.
I believe yours is message with object, not specific message. I think the first transition. Check that.
Sure.
From susceptible to.
Yeah. It's a message. Yeah.
It's a message, but not particular message. It's just
Oh, okay. Okay, so what John is saying is that this exposed name is overloaded. It's referring to the state and it's referring to the active exposure. So I think I will change this to exposure. Okay? Exposure is occurring. I apologize. We're going to have to change it to exposure so that it's not, so that it's clear. There's another way to deal with the ambiguity, but this is the safest way. Actually, you know what? I'm sorry. I think the safest way, the way with least work, is to keep this as exposed and change the state chart name, the name of the state in the state chart, to something else, because there we don't refer to it anyway. So I will say, I will change it from exposed to latent. How's that? To latent instead of exposed. Just the name of the state chart. I kept the name of the message to be exposed. And then we don't have to worry that it's confused. We don't have to change more than one thing. We just change latent as the name of the state. Who needs help with that? Okay. Who needs help? Help? Clara? No? Okay. Okay. Okay, run. Let's make sure it runs here, and we are okay. I am. Are people getting infected in yours? And they're getting cured. Okay. Well, I'll be. Okay, I'm going to go to the infection message, and it's on. Oh, it's on a particular message that now says latent. Hot diggity dog. Okay, this is the message should be exposed. Let me go search. This is another thing you can do in your models. I'm going to go search everywhere it says latent, and I see that it says it in the state chart name, but just in the name. Okay, now it should be fine, I think, in mine. It was actually tried to be intelligent in changing that as well. But I wanted it to stay the same. Okay, here we go. Great. Okay, ladies and gentlemen, people are getting cured in the clinics. They're returning home and getting cured. But the prevalence of infection remains dauntingly high, despite the fabled existence of the healing beam. Okay? Now, we're going to undertake one more step here. One more step. I was going to say this will be our last, but that sounds like a grim pronouncement. This will be our last step. Okay. Ladies and gentlemen, we're going to have healthcare resources limited by resources. Okay? Availability of a resource. So now what we're going to do is we're going to drag this over. Well, by the way, I should have shown with the clinics, if we ran this thing, we would find that clinics are being visited and visited frequently by the agent. So I'm going to be running this full tilt. I'm going to go down from here and go take a look at one of the clinics. I'm going to look at City Hospital. Is that okay? Here's City Hospital. It is currently treated with the healing beam that lies within. City Hospital has treated 600, now 700 individuals. Let's take a look at the time measurements here. Whoa. Time measurements, and just see some of the statistics. So there have been over 1,000 people treated within the confines of the beam in City Hospital, with the mean time that's been required from start to finish of 0.04 days. So the healing beam is working, and working well within City Hospital. But even yet, the infection stays prevalent within the community at high rates. There's lots of risk behavior that's going on, and individuals are exposed. They're presenting for care at the clinics, but it's not able to keep up with the spread of infection. Now, the next step, and the final step in this model, is we're going to take a look. We'll put in place a correction tomorrow morning. We'll note a correction that I put into place. But here, we're going to have resource-limited care conferred, and I'd like to show how that's done in a DES model. So we're going to go to the clinic. From the palette, we will repair to this process modeling library at the top, and we are going to drag in a resource pool, and this will be called healthcare workers. Healthcare workers. It'll be capacity 1. There's one healthcare worker. That's sub-step A. Next, we will drag in to this workflow something called a seize block. Okay? And that will be called assign or allocate HCW, allocate a healthcare worker. Okay? For this block, that's going to take a healthcare worker. For us to continue beyond, we need to have a healthcare worker assigned to us. So we need to specify the resource set to use. We are going to specify this to be, we're going to specify it with the plus, to be the healthcare workers. We'll need a single, hence the one, healthcare worker. Okay? Okay. And you notice that there's a queue associated with this. So we actually don't need the previous queue in place, or likely won't. Next, so that's where the healthcare worker has to be obtained. As long as it's not obtained, they're going to sit there for now. Next, we're going to drag in a release block that comes after the treatment is conferred. And this will be called release HCW, meaning release the healthcare worker. Okay? And that release of the healthcare worker will allow that worker to get on to other patients. Release healthcare worker just says, okay, what to release here? And this says all seized resources, so that's fine. Whatever seized resources have been seized by this entity, this agent, they'll be released here. Okay, let us now run the model. Okay, here we go. We're going to run it. Okay. Now we still see a number of individuals there. I'm going to take a look at City Hospital. Okay. Now we can look at the healthcare workers and see what fraction of the time they're in demand. Here we could see 7% of the time the single healthcare worker is in demand. Presumably a reflection of the fact that we are dealing with a quite small population here. Okay, and if we look at the time end to end, it's pretty much the same as before. we're not that stretched in terms of resources. We will now change to a larger population. Well, we could. Okay, I'm going to, yeah, it's going to require some network because it's going over to the GIS server to get information. So the other thing that I'm going to put into place here is I'm going to put into place a balking transition. So if individuals aren't treated within a certain amount of time, they may leave. If they have to wait for more than a certain amount of time, they will leave. So I'd like you to go to the palette here. And actually, you don't even need the palette. You could just double click here on this transition. Hey, come on. Double click. And we can drag it over here. We'll actually drag it up here. I'm sort of clicking along the way. And I'll finish it here, okay? Next, I'll do a time transition, a measurement point there. A measurement to measure how long it's taken them to reach there. Time measure end here, okay? Time measure end balking. This is leaving without being seen. And then I will, and the question is it connected? We have to get it connected by moving it until it's green. You could see it's connected to this guy. And then I'm going to connect it here from there to the end here, okay? And this looks a bit awkward, so I'm going to double click on this to adjust it like that. And for this time measure end, I'm going to say that it measures from the time measure start block. So both this one with balking and the one below are measuring the time since this individual passed this point here. Okay. Now, right now, the chance of balking is actually quite small because there's few the treatment is quick. We're going to go back to the treatment, and the population size is small. And instead of requiring 0.5 hours between 1.5 and 1.5, we'll change it to 1.5 to 1.5 days. Okay? So they have to be treated for some time over the course of a day. As we'll see, that will lead to rather different dynamics. Now, having done that, so what did I do? I connected from this transition, and really I'd like to zoom in here so that people can see this more closely. Here it is. It's up here. There we are. I connected from this transition up here. I added this time measure end balking. I set that to measure time since time measure start, and I connected it up to the exit. The final thing I need to do is I need to say under what conditions do they balk. Oh, I also set the treat to go from 0.5 to 1.5 days. And finally, for this seize block, I needed to say, okay, excuse me, yes, the seize block. I need to say, okay, under what conditions will someone balk? Okay, and I believe it's under one of these advanced tabs. Yes, it's I think the first one. There's enable exit on timeout. Oops, timeout. In this C's block, enable exit on timeout. Here, come on. And the question is, after how long do they wait? Will it be too much? And I'll put down 4 hours. Okay? If they wait for 4 hours, they will leave. Now, I could draw this from a distribution, because each time some people might have tighter time constraints than others. They come in at different days of the week or with different personal responsibilities. And I might draw it from a distribution. Maybe I'll do that. I'll draw it draw from a uniform distribution between 1.0 to 6.0 hours. Some people are willing to wait longer. Some people are more impatient. People are at different conditions. So it's drawn from a uniform distribution between 1.0 and 6.0 hours. Okay? Okay, great. Okay, who needs a bit more time, or who needs me to review something I just did? The model is now substantively complete. I can't think of anything else that's required. Anyone else need me to show something?
So what does that mean? The cancel the unit there.
The cancel, sorry?
Cancel the unit.
What do you say?
You know. Yeah, there.
Looks great.
Yes.
Oh, that means I think maybe if a healthcare worker is requested and then they balk and leave, they go out by this timeout, then their need for the resource is no longer present. And the question is, should the resource still come, thinking that they're needed, and the person's gone now? In which case they may have to take time to move there. Or do they know that, oh, that person's gone, I don't have to worry about them? There are many contexts where we use this sort of discrete event modeling in a spatially explicit way, where there might be some distance that a nurse or doctor has to move to see someone. And if someone was in the room before and the nurse or doctor comes to treat them and they're gone, they've just wasted the time there, is the idea. You see what I mean? I believe that's how it's used. The cancellation can occur in the case of timeout or balking. Okay, so let's run this. Let's run this model here. And now we have a much longer time to cure. We're going to go to the city hospital. And we see that actually the city hospital has conferred treatment to I'm going to pause it for a second. It's conferred treatment to 157 individuals, but 346 individuals have left without being seen. Okay? We can go look at the statistics. Those individuals who were conferred treatment here were conferred treatment in approximately half a day on average. By contrast, those who balked typically did so after just 0.138 days, or they left without being seen. And so individuals are balking quite closely, quite quickly. What could we do? You notice this healthcare worker has a utilization of 76%. What do you think we could do to lower the balking rate here? What could we do? Notice that their utilization is like 77%. What could we do? Well, what we might do is what? Have another healthcare worker. Okay, so the number of healthcare workers could be larger. Now, the right way to do this is with a parameter that specifies the number of healthcare workers to use for clinics. In the interest of expedience, because I really want to get you out of here, and we're gonna have project work, and we're gonna have work with our Java tutorials. I'm just going to go to the healthcare worker resource pool, and I'm going to set its capacity instead to be 4. Okay, to be 4. And now let's go see. It's a shame that we haven't had time to add in a graph of the number of people infected in the population, because this model jointly simulates the service delivery process together with the population health. But one thing that's clear is we see a much lower usage associated with the healthcare worker. Their utilization is much smaller. But we still see a distressing amount of leaving without being seen. Okay? So we still haven't met that need. And in terms of the time needed to treat those who have left without being seen, who are being treated, we're still dealing with a mean of about a day's time required, which is not surprising. Meanwhile, for those who are leaving without being seen, they're still leaving. So we lowered the healthcare capacity. We enhanced this healthcare capacity. We lowered utilization, but we didn't materially impact the number of individuals who left without being seen. Let me ask this question. You see that the prevalence of infection, despite increasing the number of healthcare workers strongly, the prevalence of infection remains distressingly high. Why is that? Can anyone give me a narrative explanation? Why does it remain so high? What's going on in a short, pithy summary? What do the statistics tell us for at least this clinic we're looking at here? We can go look at other clinics, but what are the statistics telling us? What's that? People are leaving without being seen. There's of the people that have been treated or have been waiting here for treatment, most have actually left without being seen. And when they leave without being seen, what happens? They infect other people for a while, and they'll probably represent. So some of these people are just going back and forth because, it's still very painful. And they keep on coming back and forth, but they're waiting so long, they say, okay, I'm out of here, I'm going to come back later, or what have you. And so we are leading to ongoing infection there within the community. And if we plotted out the prevalence in the community of infection, we would see a quite high rate of infection remaining. In order to deal with this, we would need to greatly open up the amount of treatment. And fortunately here, in the treatment block, you'll notice that we set the capacity for treatment to just 1 at a time. We're still at a model where we have just one resource, like a room here. Let's set it up so that the only blocking resource that's limiting people is in fact the availability of healthcare workers. So we'll change the treatment block to have maximum capacity. So what's limiting it now is the allocation of the healthcare worker. Can we do that? It's not the availability of the healing beam that used to be the issue, in Jeff's words, but rather the healthcare worker that stand in front of it. So now if we look with 4 healthcare workers, what we will find is, if we run this out, we'll go down to City Hospital, and we notice that we are treating a much larger fraction of individuals than are leaving without being seen. We only have hundreds treated, 200, so 300 versus 17 that have left without being seen. And take a look at the prevalence of infection. It's not small, but it's somewhat lower here. And of the individuals who are getting treated, their average time to treatment is now a bit lower. At least it's about one day here. Okay, we see much lower utilization for healthcare workers than we originally saw. Okay, so here we have multiple individuals being treated at once. You notice this is oscillated between 0, 1, 2, 3, and occasionally 4. But it's still taking a while for them to actually make it through the treatment. And right now, they're still transmitting while in that state. We could simulate it so they don't have any contacts in the hospital, but I think I'll leave it like that. So this is a hybrid model, ladies and gentlemen, a hybrid model of individuals in the community circulating in a population, engaging in behaviors heading back and forth between home and work, connecting to people at their local situation. At work, they connect to their colleagues. At home, they connect to their families. They bring infection back and forth between them. They can spread it to others wherever they are. So if the first person infected was a worker at a certain facility or in a certain family, they might spread it to family members. They bring it to their workplace, to the workplaces of the different family members. It spreads there, brought to different homes. And meanwhile, when they feel ill enough, they present for care at a clinic and are conferred treatment, in this case by 4 healthcare workers. They move back to the community, but sometimes they go right back into that workplace where they're infected again, because there's no long-standing immunity from this infection. And we're not able to treat even the presence of the fabled beam of treatment wasn't able to bring down that prevalence of infection at enough level to snuff it out. Okay, and even the presence of 4 healthcare workers, while it helped a bit, it didn't allow us to reach that critical tipping point where the infection died out. The fire still rages, beam or not. Okay, individuals within the community come into the clinic. They are treated in the clinic. The treatment here represented as perfect, but we could have used alternative outcome, sends a message to cure them, and that message, when sent to a person, leads to them to recover from back to a susceptible state. But that there presents danger because they go right back into their infected workplace if they're not careful, or their infected home, at which point they can become infected again. We could have put in a recovered state for some time, a temporarily recovered. That would change the dynamics significantly. So we have this model. It's a hybrid model. We have individuals in GIS space going to clinics with known locations, empirically grounded locations. The evolution of the population health is affected by service delivery in the facility. The demand for service delivery and the number leaving without being seen is affected by prevalence in the community. So you have this interplay of population health and service delivery that in many ways is characteristic of our broader systems. Okay, that completes the GIS model. It also completes a model where we saw an infection spread process, and a model where we characterized the dynamics associated with the service delivery in the form of discrete event modeling. We also had within this context a brief look at the flexibility offered by GIS. So that concludes our formal model building for today. I'm going to prepare in a few minutes to deliver a Java tutorial. Others may wish to pursue project work for the balance of the day. I think we have us down for going for another hour or hour and 15 minutes. Okay, so that's all for today. Thank you very much, and I'll see some of you in there for the Java tutorial shortly. I will upload it immediately. Yeah, thanks. There we go. Okay. It'll be called version 4. Version 4. Okay, great. And I'll save the recording.